It's my pleasure to introduce our moderator for this session, Louis Shuler, who's the head of innovation at Alpine Group. Louis has a passion for material innovation and advanced manufacturing. For most of the past 15 years, he's been living in China and leading textile innovation and sustainability initiatives for the world's largest sportswear and fashion brands. Aside from roles at Under Armour, Gap, and Stance, he has consulted for over 50 apparel and footwear brands around the world. And I will leave it to Louis to take this panel. Thank you. I'm really looking forward to it.
Yeah, thanks, Nicole. So really excited. Biosynthetics is an important topic in the industry, and there's a ton of potential in that space. So just to kind of give you a quick overview of the plan here, we'll do about 5 minutes of introductions for each of the panelists. And then we'll kind of spend about 25 minutes diving into some talking points, some really important areas, some topics within this space. And then we'll leave the last 15 minutes for questions. And, I guess if questions start coming in and, may be good to dive into some questions if we get some good ones and have time. So I guess to kick it off, maybe Charles Dimmler from Checkerspot, if you'd like to introduce yourself and talk a bit about the work that you guys do.
Sure. Thanks, Louis. And everybody, please call me Charlie. I always introduce myself as Charles, but everybody calls me Charlie. So I'm the CEO and co-founder of Checkerspot. We're a materials company, and we're creating high-performance materials that are really enabled by biology, biotechnology. And the way that we do that is by utilizing microalgae, single-celled organisms that we ferment. So think very similar to brewing beer as an example. We ferment the microalgae to produce oil. And oil is where we can really direct and be specific about the types of chemistries of those oils as an alternative to petroleum or as an alternative to some of the nastier commodity-based vegetable oils. And we're doing this because we see a future that allows us to move beyond petroleum, a future where we can create high-performance materials that have novel performance properties, physical properties, functional properties that you can't get or can't easily get from petroleum or commodity vegetable oils or even other commodity-based feedstocks. And we started to bring that to life at Checkerspot. So we're now still very much a startup. We're a small company. We were founded in 2016, so coming up on 6 years old. We are based, we're headquartered in the San Francisco Bay Area in Alameda, but we also have a pretty large footprint in Salt Lake City, Utah. We have about 65 people on the team currently. We're venture backed. We've raised a little more than $50 million to date. And today we have 4 materials that are on the market. 2 are urethane based. 1 is a textile finish. And the 4th is a novel oil that we're actually commercializing in the personal care market. So a little bit afield of what we're talking about today. But those 4 are what are currently on the market. We also have a bunch of partnerships, like what we're doing and what we're passionate about, what we're working towards in pursuit of this mission, which is to expand the palette of molecular building blocks that allow us to bring performance materials into the world that have the added benefit of being more sustainable. We can't do this alone. We have to do it in partnership. The vision of the company is very much around empowerment, about putting these tools, these technologies into the hands of third parties that have existing infrastructure, distribution, market expertise, so that we can really make a dent and impact on things like climate change and improve materials and ingredients for human health. So to date, we've announced a few partnerships, notably with the Japanese chemical company DIC, We've also announced a partnership or relationship with WL Gore. We have a really foundational, important partnership with Beyond Surface Technologies. That's who we're commercializing the textile finish with. Midori BioWick, many of you may recognize. We're supplying oil to BST, and we're also co-developing some other textile formulations with BST. And we also, as part of our innovation platform, which we refer to as the Wing platform, we've come to market with our own consumer brand. And I'll just spend 1 second talking about that before I pass the mic on. And this consumer brand is called Wonder Alpine. And it's an outdoor recreation brand that we view as being a really critical part, an extension of our laboratory. It allows us to have consumer engagement. It allows us to have directionality in our product development activities and to demonstrate and to bring to life the physical properties of the materials that our core platform is innovating. And as a consequence of the success with Wonder Alpine, bringing to market initially backcountry skis, and we have some new SKUs that we'll be launching shortly in the next few months. That's really served to de-risk the use cases of these materials and driven demand and sales, again, in the spirit of empowerment. And so one recent example of that is the largest US-based ski manufacturer, DPS, announced that they've been working with us and are taking Checkerspot materials to market in the Pagoda line of skis. So hopefully that gives you a sense of what we're doing, a little bit of at least a teaser around what's possible with biomanufacturing and biology in the pursuit of performance materials that allow us to unlock a post-petroleum future and that have the added benefit of being more sustainable than the alternatives.
Awesome. Well, thanks for the intro. Excited to dive into some questions here soon and find out more about the work you're doing. So next, Pasha Whitmire from Patagonia. If you'd like to do a little intro.
Sure, yeah. Thanks so much, Louis, and so happy to be a part of this panel and the Material Innovation Conference. It's great to have all these brilliant minds together and really helping to push the envelope forward on sustainable progress. So I'm really excited to be here. And yeah, I work at Patagonia. For those of you who don't know or aren't familiar, it's a outdoor apparel company founded by Yvon Chouinard, a famous climber. We've been in business for coming up on 50 years, and we're mainly in the soft goods space, but do a little bit of bags and equipment as well. My area of expertise is material development and material innovation. So I'm actually, my specialty is in the synthetic space and the technical performance materials. So I spent a bulk of my career developing a lot of the waterproof breathables at the company, and also kind of putting together this synthetic strategy kind of moving forward for our company. So yeah, I've been here for 9 years and been in the industry for 10, and yeah, excited to be here.
Awesome. Yeah, thanks for the intro. And then Alissa Baier-Lentz, if you would like to introduce yourself and give us a little bit of info on Kintra.
Sure. I'm excited to be here. So Kintra Fibers is a material science company, and the core of what we do is turn sugar into things like sneakers and silk and satin and almost any fabric you can imagine. And we do this to get the plastic out of your closet. The reason being, as I believe everyone in the audience and definitely around this roundtable is aware, the majority of textiles are petroleum-based and non-biodegradable. And at Kintra, the core of our company really starts from my co-founder, who's the nano engineer behind our material. He's also a surfer, And it was actually the Patagonia study on microfiber pollution that really put this concept of the materials that enable this human connection to nature are the same materials that are polluting these natural environments that allow humans to get out into and explore. So Kintra started with a simple question that my co-founder posed to himself, and it led him down, a train of research that I joined him on afterwards to help commercialize our product. But that question was, is there a way to do this, but do it differently, do it in a way that's aligned with nature? And so at Kintra, what that means, being aligned with nature, means starting from the earth, so from bio-based sources, being compatible with the earth, so compostable, as a way to address microfiber pollution and also address textile waste in a new way. But we can talk about all those three things throughout this panel, because I think it's also the core of not only Kintra, but the topic at hand, biosynthetics.
Awesome. Well, thank you. I think that we've all spoke, and we know that it'd be awesome to dive into some deep technical discussions here, but I'm sure that there's some that are joining us that are new to this space. So would one of you like to kind of give an overview of how you define biosynthetic? If anybody, I mean, I think Pasha, it would be quite interesting, you coming from a brand. Yeah.
Sure. Yeah, I'm happy to start, and Charlie and Alissa, feel free to fill in. But I kind of think of biosynthetics as a very general and overarching term to describe polymers that were derived from non-fossil fuel based feedstocks. So that can encompass a couple things, though. I mean, I think when we talk about the world of biosynthetics, there's kind of two things that come to mind, and that's like biopolymers or bioplastics, and there's also biodegradability, and they aren't one and the same. So I think perhaps they're both biosynthetics, but I think it's important that we define what a biopolymer, a biosynthetic, or bioplastic is, and then we also define what a biodegradable material is.
Awesome. Charles, Alissa, anything to add to that, or pretty spot on?
I think that that's pretty spot on. The one thing that I would add is that it's complex. It's extremely complex because, for instance, let's take wood as an example. And I just thought of this, Lewis, because I can see the wood in the construction of the building. We were talking about this before the session started that year in Amsterdam. And I would bet that the wood in that building is now a few hundred years old. And we think about wood, it's clearly bio-based. And you think about wood, we know that it will biodegrade, but only under the right conditions. And so it gets really complex, and I worry sometimes that there's an attempt to oversimplify what bio-based means or what biodegradability means. And unfortunately, it is complex and it is nuanced. And so I just want to put that out there, that we could probably spend the entire time unpacking exactly what that means and how, as a practical matter, it's applied in the context of product development.
Yeah, good point. I mean, here's just like a thought, is something that is partially bio-based, could that still fit in as a biosynthetic, or does a biosynthetic need to be from fully bio-based inputs?
I think the convention right now is that if it's made, if it's man-made as opposed to naturally grown, that there's a level of synthesis involved. And so when we think of biomanufacturing, we are making, or we are synthesizing and producing something, even if it's through biological means. And I think that and I think Pasha hit on this, there's a really good contrast point between synthetic which often has roots and connotation with chemical derivation relative to biosynthetic, which is biological or biochemical derivation.
Nice. Yeah, I think so. Those are good points. So, a question is, Alissa and Charles, as you guys are innovators working on new technologies, and Pasha, you're evaluating them and which are the most viable for the company. I'm curious to know, when it comes to evaluating a new technology, what are the main drivers? Considering whether it's feedstock, processing, end of life, and then kind of within those three buckets, diving deeper into environmental impact, cost, durability. There's just so many things to consider. How do you kind of measure those and prioritize what's most important? And then I guess, like, going from there, which are the ones that would either lead you to continuing on evaluating a certain technology or saying that's not what we would consider viable?
Yeah, Louis, I feel like you gave a great little summary of kind of what we go through when we're kind of in that new product development process. But yeah, I mean, I think when we're looking to create a new product, we're always trying to think about what are the most ideal or best materials to be using for that product. And, sometimes, like the clothes I'm wearing right now, everything I'm wearing is made from cotton. And, for this kind of end use, it makes total sense for me to be wearing something like this, and, it's comfortable. But when we think about some of these performance applications that we're designing for, whether it's, ski shells or alpine climbing shells or base layers and puffies to keep you warm and dry, a lot of times we're looking at synthetics, and there's a lot that goes into those, right? Like, I think if you just look at the care tag or care label, a lot of times the Federal Trade Commission here in the US only requires us to call out what the fiber content is. But to the trained eye, actually, there's many different materials that are going into one garment. And especially for a complex waterproof breathable, we might have a polyester or nylon shell, but then there's a polyurethane coating or lamination that might make up for 30% of the entire weight of the fabric. And then also a backer in the case of a 3-layer. And then there's glue, there's chemistries that, Charlie's working with BST on, and all kinds of stuff that goes into it, and finishes. So when we look at all these things, we have to kind of consider what is the ideal. And I mean, really the ideal is thinking about the beginning and end of life to start. And that beginning of life, ideally, we're using some sort of waste feedstock. Certainly a rule of thumb is we're really just trying to move away from non-renewables and move away from petroleum usage, right? So that's kind of the bare minimum. And then from there, a lot of times when we look at the carbon impact or the water impact, it might make the most sense to incorporate some sort of post-consumer or post-industrial recycled content. But then sometimes we'll look at a material where that may not even be available, or it's not possible. Or maybe there's a performance reason why we might need to be considering other kinds of inputs and feedstocks. So that's kind of when bio-based starts coming into the conversation. And there's things like our current torrent shell, for example, where there's a portion, and earlier, Louis, you asked that question about, like, is it okay if it's partial? Like, yes, absolutely. Like, I think any progress we can make to move away from petroleum, the better. And to Charlie's point, everything is built of all these different chemical building blocks. So, today commercially available polyurethane, like, we can really only source polyols that are bio-based, and the isocyanate portion is pretty difficult to find any kind of renewable source or feedstock for. So, that's where we start kind of getting in there and picking out the different kinds of materials. And then finally, it's really considering the end of life, and is it possible to recycle? What does biodegradability look like, and what kind of environments, and how do we manage that? And yeah, like when it specifically for biosynthetics, you asked me a lot of questions at once, by the way, Louis. So I'm sorry I'm talking for so long. So like with the feedstock, we really have to think about like what are the implications around it? Like, is it GMO? Is it competing with food ag? Is it a waste ag? Which would be fantastic. Is it responsible for deforestation and then endangerment of species? And the list goes on: pesticides, herbicides, and all these sorts of things. And so yeah, like when we're considering the feedstock, it's really important to look through those sorts of things and make sure there's no kind of regrettable like implications around what kind of sources we're using.
Can I ask a follow-up question before we continue to move around? I'm going to give the mic back to Pasha in a second. I'm really curious, Pasha, when you think about things like deforestation, or you think about questions and topics around the safety of synthetic biology, or the agricultural practices for feedstock and fermentable sugar, which are all critically important. But at the same time, it can be very easy to find something upon which just to say no, like we're not going to move forward with a particular technology. And so therefore, we're going to continue to use a petroleum-derived thing. How do you think about that trade-off? If we, and I think consumers are very clearly aligned around moving towards a post-petroleum future. But if we're not working to figure out ways to further advance and adopt biological-based solutions, then aren't we going to just continue to kick the can down the road and stay addicted to petroleum? How do we think about that trade-off?
Yeah, I mean, I think that is an excellent question. And what I think about is really, my mind kind of goes to like the recycled conversation and kind of how a lot of the outdoor apparel industry has kind of adopted a lot of recycled content recently. And I think if you look back at the history of that, especially in performance materials, for the longest time, like we weren't even considering recycled content, first of all, for performance materials, especially Patagonia, where we were so concerned about like building the best product and the highest level of quality. So it wasn't even on the table. And then kind of in the last few years, we kind of started to be like, oh, maybe we can incorporate recycled content in these performance materials. And then now our entire performance line incorporates recycled content. And now we're kind of asking ourselves like, well, where are these recycled materials coming from, and what good are they doing? And are they made from meaning, and are they solving world problems? Right. But if we would have asked ourselves those questions way back when we were like, oh, it's just coming from plastic bottles, like that's not really helping the world, like maybe we shouldn't do this and we'll just keep using petroleum. So I love thinking about that same kind of ideology for bio-based, because I think this is getting started. And absolutely, I think we can really hit this roadblock where like if every single like thing isn't perfectly checked off and like exactly what it needs to be, then we don't do it, like it doesn't create the space and that foundation for us to actually make progress. And so I absolutely agree that sometimes, maybe it isn't quite perfect, that we can at least get it off the ground, capsule collection or whatever, to kind of like help support an initiative, but then like really do that work with an organization to kind of outline what does that North Star look like for us, and what does that ideal feedstock look like, and kind of set a path forward to get there one day. So yeah, I love that thinking. Absolutely.
Yeah, it's kind of similar to like textile recycling today. There are technologies that it's all about progress over perfection, right? It's like there are technologies that are out there. There are technologies that are coming in the next few years that, enzymatic recycling that's going to have reduced impact, that are super exciting. But in order to get to that spot, the wheels need to be moving. So there's infrastructure built and investment into those areas. And bio-based, biosynthetic, very similar.
I think that's spot on, and at the same time worthwhile for all of us, and as an industry, as a segment, to be aware of the competitive forces and the inertia that exists around adopting new ways to create things. Because from my vantage point, and I've been in biomanufacturing now for 15, 16 years, and when I reflect back over that timeline, there was a point in time when there weren't biologically derived materials and textiles and finishes that were available. And then all of a sudden, there were companies that started to come to market with these things, and it became clear that it was commercially viable. And then around the same time, it was very interesting that the petrochemical industry started talking more about this need to think about product at the end of life. And then what we found in the market was that there were some groups that would say, well, hold on, like really interesting Checkerspot that you can create this material, but is it biodegradable? Because we're really interested in biodegradability. Like, well, yes, it's biodegradable, but in a few hundred years. That's not good enough. And so what as a consumer brand are you going to do? Well, we're going to continue to use the petroleum derived stuff that not only is damaging the environment and not healthy for human health, but also is not biodegradable. And so there are these, what I'm encouraging people to consider is that there's signaling in the market that is pushing us down a path to slow the adoption of technologies today that are commercially viable at a time when we're running out of time. We're in a race against the clock to mitigate climate change. And so I just want to put that out there, that we should be thinking about what we can all do to help move us towards a post-petroleum future and not get caught up in some of this inertia.
I'll jump in because Charlie, I love the question that you posed. And I think, we see that at Kintra as well. Often in conversations with customers about a pilot project, which we're kicking off, we get asked, are you using a waste stream feedstock? And that's a valid question, but typically I'll pose it around and I'll say, first of all, today we're using, we're such small quantities. We're just in our early stages of getting towards commercialization. But today we're using corn that was never grown for food use. But is corn good enough? Well, our preliminary LCA that was done by a third party shows that we reduce emissions by 95% compared to traditional PET, just using the worst farming practices, traditional feedstocks such as corn or wheat, based on the third party LCA that we got back. Now, we have the potential to use a huge variety of sources for that fermentable sugar for people like Charlie to transform into our molecular building blocks. So we can choose, and it's on us to change the conversation around, are we taking a waste stream from conventional farming, and pose it back to the brand and say, would you like to partner with us to work with a regenerative farm where we can derive our feedstock, we can get it to Charlie can get us our building blocks, and we can build the best product possible. So it's about changing the kind of conventional questions and turning them into how can we collaborate, because we are on a ticking time bomb. We are on a clock. So how can we, work together to get products to market quickly and effectively, while also ensuring that when we do scale, when we do displace the 57 million tons annual production of traditional PET for textiles, that we're doing it right, that we have these partnerships in place, that we have done our homework on what is environmentally the best feedstock, but also what is economically viable, and who are each of the value chain partners along the road that can get us there. So that's kind of how we've approached a lot of those conversations. And I have to say, even after just the 2 years that we've been around at Kintra, these conversations have changed from, does this fit our checklist, to how can we work together to get it to this North Star that we can co-create.
Awesome. I know, Alissa, that Kintra is a compostable fiber. So can you talk a little bit about how you're evaluating compostability?
So we're in the early days of that, but the chemistry that my co-founder based our research on, Billy, that he based our research on is called PBS, polybutylene succinate. It's a known compostable polymer. It's been widely studied. It's typically used in injection molded applications, films, things like plastic forks and knives, single-use packaging, areas that Kintra will never address. And what my co-founder did was took this base chemistry, and the best way I've ever heard him describe it is he took a regular car and turned it into a Lamborghini for textiles. So it can survive a huge variety of different processing that's required, specifically and unique to the textile market, very different from, if you're making single-use packaging. So another way is he took a dumb polymer and made it applicable for the fashion industry applications. And so again, the reason that he selected this base chemistry to start the research is that it's been widely studied. It's a known, inherently, intrinsically compostable polymer. Now, our job is to ensure that any post-processing that we do, and of course, the actual chemical changes that my co-founder made, didn't negate this compostability. And as an early startup, we worked with the Compost Manufacturing Alliance to test fiber samples that have been fully dyed using a traditional dispersed dye with off-the-shelf dyes that we purchased that are commonly used for PET. And the results from the Compost Manufacturing Alliance study, which is a soil burial study, came back that our fibers compost in about 49 to 90 days. Our next steps are to go to full certification and study and ensure, exactly when, what conditions, send them a variety of types of different fibers and fabrics and different materials, and really kind of do our homework and look for that. And that's where the full certification comes into place. With that being said, an area that we're really focused on is what are the impacts of fiber as plastic, microfiber pollution that is shed through laundry and in everyday wear and tear. And unfortunately, from what we've seen so far is, the studies that are out there, the certification studies are not really optimized for this. Of course, the work that Patagonia is doing with OceanWise is really advancing this forward. And we are part of the Microfiber Consortium, and the OceanWise Plastics Lab is a part of that as well. And I know there's new studies that are ongoing that look specifically at this microfiber impact and how can we measure that? Can we study and can we mimic real world conditions? So that's an area that, again, we're going for the full certification, checking our boxes there, and also participating in this kind of new area of research that the industry, all of us, innovators, brands, manufacturing partners, kind of need to start studying more, is this microfiber shed impact, and really looking at that and understanding it in full. So that's an area that's kind of ongoing, I think, for everyone, and a part of what we're looking to be active in at Kintra.
Yeah, I think that's interesting. And like even going beyond that, there's so much focus on microplastics, shedding, fragmentation. But, you mentioned you buying off the shelf, you've purchased off the shelf dye stuff and dyed the fibers and done the compostability testing. I'm curious, what about, beyond the fiber, are you guys also looking at the dye stuff that's used to colorize your fibers? Are you running ecotoxicity testing and evaluating, as any of those colorants break down, how those affect biological systems?
Absolutely. And that's an area where now that we're starting our pilot projects, that's where we're looking with our brand partners. So understanding, hey, what kind of dyes are you currently using? What are the non-negotiables, those metrics that we need to hit? What are those compliance metrics that we need to hit? And then if you're not so vertically integrated that the brand that you're doing it in-house in your own supply chain, who is that dye house that you're working with? And in our case, one of the most commonly, frequently used dye houses has actually reached out to us to be a partner in exactly this type of research, to ensure that any dyes that are used are aligned with our promise to nature at Kintra. And then, even looking beyond that, like the work that Charlie's doing with Beyond Surface Technologies, what are the finishing chemistries that are being used, if any, for that product, and really working backwards. So for us, when we set out to develop a new product, it's really looking at that performance, both from an environmental perspective. What is that product going to be used in? What are the different manufacturing steps that will deliver this performance benefit? But also, how does that affect the environmental performance of this product throughout its life cycle? And again, it's a big task. And I think our job at Kintra, it's starting from the materials perspective. How can we design from the molecule forward to make sure that we have a chemistry that addresses this. Sorry, my coffee machine is making noise in the background. And then also our next responsibility at Kintra is aligning every manufacturing partner alongside our goal of delivering this environmental responsibility.
Nice. And so, we're talking about compostability in relation to fiber shedding, right? But it's also pretty important if we're working on new biosynthetics that they're also recyclable, and understanding that, it's recyclability can become difficult, because it's like, is it recyclable within current recycling streams? And so both Charles and Alissa, I'd be interested to hear your take on recyclability, and how you guys work within new technologies to make sure that that's possible.
I mean, yeah, with recyclability, I prefer thinking about upcycling as opposed to recycling. And specifically with, for instance, the proprietary urethanes that we've developed that we're commercializing through Alpine and with others. We've developed a process where we've really minimized waste in the manufacturing, because this cast urethane is poured and then cures, as opposed to what's conventionally used in ski construction, which is ABS plastic that's milled. And so there's a lot more waste with ABS plastic versus this cast urethane. But there's still some flashings in the manufacturing process that we collect, and we've actually innovated new material based on those flashings that have physical properties that we haven't been able to identify in other areas. And we're going to come to market with that material soon. That's about all that I'll say on that topic right now. But that's taking a waste stream and uplifting the value. Now, we started with flashings, the manufacturing waste, but we're also in our ski construction using a specific resin that is soluble. And that's really important, because then we can potentially take product back at the end of life and solubilize it and pull apart the constituent materials, or reuse those constituent materials in this new material that I just described, that we've prototyped and brought to life through the flashings. That's taking something, again, that's reached the end of life, that in the conventional thinking would be a waste, would go to landfill, but creating more value, uplifting it as opposed to recycling it. That's how we're thinking about it. And we're trying to apply that lens across all of our materials innovation. Now, the second consideration is, right now, from all of the data that I see, and I would invite any of the panelists or any of the listeners to follow up and show some evidence to the contrary. But right now, the recycling model isn't working. Nothing is being recycled. And that really worries me, because there's a little bit of a fiction that recycling is the panacea. Like, that's the path that we need to take. And it's a version of what I was trying to articulate before, where this is inertia that exists within the market to ensure that we stay addicted to petroleum, that we don't execute a change, a transition. And so I hope what's coming across are two things. One, that as we innovate new technologies, whether that's at the consumer product level or whether that's upstream with the monomers and the materials and the textiles and the fibers and these considerations, that we're designing it with intention. We're thinking not only about how do we source better materials that perform better, and where we're taking into account what can happen at the end of life. Thinking about that in a circular fashion. I know that there are others that are. That's the first point. The second point is to be really wary of falling into the trap that there are these silver bullets or these cures or that recycling actually works. Because the data that I see, and I've been studying this for years, doesn't support that that's a model that's viable, that's actually happening.
The system is broken. I completely agree. And again, where we sit at Kintra is the start of life, the material design. So for us, we look at designing forward for circularity. And we look at that in two ways. One is fitting these future forward systems that are starting to develop. It's a long way to go, but fitting, designing textiles for mechanical recycling ease and simplicity. And we do that through performance. From speaking with a few companies focused on mechanical recycling, our understanding has come to be that monomaterial construction is a big benefit for ease of mechanical recycling. So at Kintra, and also for chemical recycling as well. So at Kintra, what we do is, how can we build that performance in that can deliver the potential for an easy monomaterial design construction from the start. In our case, our material is strong, it's soft, and it also has some stretch recovery. So that can eliminate the need to blend with small amounts of spandex. Again, and it could also potentially eliminate the need to blend with natural fibers, even though we love natural fibers and we could blend with them. But if, again, the goal is to create a monomaterial construction, because we have a hand feel like cashmere with the strength of synthetics and that stretch recovery, it makes that all the more easy to have that drape and fit that you would typically only achieve through blended fabrics. You can do that just solely with Kintra, again, in our early fabrics that we're making. And then the other thing is what we're really excited about, and an area that we are, it will take a long way to get there, but an area that we're hoping, really can develop is working with resale partners. Resale is booming, working with the Goodwills of the world and bringing these people into the design conversation and thinking about, look, like when you donate something or when you are getting rid of a garment, typically you either resell it or you donate. So there are these inherent systems that we have built in. So how can we create a world where these are partners with the brands, with the innovators, and we can work with them? They're already sorting materials. So instead of after an item is resold 10 times, and that's really reached its end of this use, how can we work with that partner to get it into the compost waste stream instead of the landfill waste stream? Or just the stream that goes to a next sorting partner that knows, okay, great, this is Kintra, it's fit for chemical recycling, this garment is better suited for mechanical, and this one goes to compost. So again, zoom out 10 years, how can we start building these systems today? And for us, it just comes down to responsible material design to help enable and be a part of these future end-of-life processes that are in the very early days today.
Nice. So I have a question. Speaking of design, do you think that some of these new materials that you all are working on, I understand there's still some work happening. Do you think that we're going to be in a situation where some of these new biosynthetics, it's going to require, textile engineers to design into some of the limitations or constraints? Could be something related to like thermal stability or dyeability. Do you foresee any of that happening? And if so, I think there's opportunities now where if you're willing to have a wider tolerance on, say, color achievability, you can greatly reduce your environmental impact. And so if you're faced with those types of situations, like I'd be interested to know, Charles and Alissa, how you propose that to brands, and then Pasha, you from the brand perspective, work with that internally, knowing that you have to convey that to a consumer.
I mean, I think it's important to look back at history, and when you think back at the history of materials innovation, materials adoption, it is characterized as a story of utilizing what was available and what was available plentifully. And that definitely characterizes the 20th century and the Industrial Revolution and the rise of petroleum. And we were visited. This is a few years ago, but we were visited by one of the leading aerospace materials engineering companies, and this somewhat introspective materials engineer made a remark, and he said, we're really frustrated because it seems like the permutations of what's possible from petrochemical monomers we've exhausted. And when you look at the petrochemical industry, there isn't, Pasha, you especially can attest to this, there's nothing new that's coming down the pike. And on top of that, and again, Pasha can validate this, a lot of the products that we use from a consumer perspective are made at the same factories, and they're utilizing the exact same materials, and there's nothing new from a materials perspective. And that's fundamentally what biology is unlocking. We can actually get to naturally occurring oils, proteins, sugars that have never been explored, never been interrogated, because coming back to my point around history, they haven't been available at scale. But now, because of biomanufacturing technologies, we can produce at scale. And that, for me, is the really exciting thing, because that unlocks the possibility, coming to your question, Louis, to work with product designers, to empower product designers, to say, Pasha, I don't care about the poly that you use. Pasha, tell me, blank slate, what performance properties would you like to see in the next generation of waterproof breathable garments? Let's go design that together. But Pasha and I both know that he'll be like, that's awesome. Patagonia doesn't take that kind of risk. We're not going to invest in a big, meaningful project that is going to explore what's possible. And that's true of pretty much all brands. And so that puts the burden of responsibility on innovators like Checkerspot and Kintra and others to go in to do that work. That's why we created Wonder Alpine, to have that directionality on product development, to bring to life new novel performance characteristics, to demonstrate what's possible, to then deliver and put into the hands of product designers like Pasha these materials.
Yeah, that's beautiful, Charlie. I think that has to be the biggest takeaway of this panel today, is that there is such a opportunity for us of this exploration in these feedstocks. I mean, you're totally right that we've been totally handcuffed and restricted of what kinds of inputs and building blocks we've been able to create from the petroleum industry. And by using oils that were made from, readily available biological material today, the universe is huge there. So thanks for saying that. It's very true. And yeah, unfortunately, a big company like Patagonia, it can be a little hard for us to adopt something in its infancy like that. But certainly we're trying to make the space for things like that. And even this fall, we'll be launching 100% bio-based like a bio-based polyester down jacket, where it certainly is like a very capsule run. It was it was done in a very limited basis, and we'll be launching this product as a capsule. So we're certainly trying to get better at that kind of thing. And I agree that that's the only way to really explore these things and get them out into the market is by making the space for it.
I think it's also worth noting that for those that are pursuing similar things like Alissa and I are in terms of materials innovation and development, to not forget or to lose sight of the factories, because the factories are, I mean, it's a black box. They're very infrequently participating in sessions like this. Very difficult to get information around what they're utilizing, why they're utilizing it. I think Pasha can also attest that even for a brand as prominent and well-known as Patagonia, that pull-through is not as easy as many of us might hope or wish or think it is. And where, again, there's inertia. There are forces at play to ensure that we stick with petroleum for as long as possible. And every day that we don't move towards a post-petroleum future, they're just making more money.
We see that at Kintra. We've been pretty fortunate to have a lot of interest from mills that are, getting requests from their customers for bio-based, for compost or biodegradable, they would say, products. But beyond that, we found that when we do connect with these companies and these value chain partners, it's on us to demonstrate not only the environmental benefit, but the economic value that we can deliver. The economic value in terms of new customers they can unlock, but also benefits their bottom line. At Kintra, we've optimized our technology, uses lower temperature dyeing processes. We spin at lower temperatures. When I say that to the chief sustainability officer, they get excited about, hey, this reduces scope 3 emissions. And there's actually policy movements happening where that can lead to a tax break. You'll get rewarded for using and demonstrating reduced emissions materials. You'll also be rewarded for designing for circularity. These are still in the works, but it's policy that we can anticipate potentially coming up in the next couple of years here. But so that there's that economic incentive that may be emerging in industry. But then beyond that, lower temperature, if I say that to somebody just kind of running the numbers, they'll see that and they'll hear cost saving. So, for us, we found that if we are looking to partner with a brand's partner, we need to lead with these wins that we can deliver for them, and then work with them to measure and make sure that we're actually delivering upon them.
Yeah, I really feel like after spending time in brands, that the real opportunity to kind of streamline and get things commercialized quicker is to be working closer with the supply chain. Where traditionally it was innovator, brand, and then at some point some development would be done and the brand would say, okay, well, who are we going to take this to and transfer it to and begin working? And I think it's very important. It's an integral part of the process to really be working as sort of like a triangle from the start, so you can satisfy the brand's needs. The manufacturer has the capabilities to kind of implement it because they understand, all of the processing that's involved. So, yeah, I think that's changing quite rapidly, and it's important because it's going to help commercialize quicker and also commercialize the right product rather than, commercializing something and then finding out, ooh, we didn't consider this. It's kind of interesting. Anyway, we have just a few minutes. I wanted to make sure that we got a few of these questions answered. So Taylor has a question for Charles. The question is, are you making bioanalogs of conventional chemicals or making chemically identical materials through greener bio-based means?
The answer is both. So we have some materials that are like urethane as an example. Like there are existing urethanes. We're commercializing 2 different urethanes. And so those would be bioanalogs, but we're also creating totally new materials based on biology or maybe even biochemistry is a more precise term, where within the single-celled organism, we're able to get to really, really unique chemistries that you can't find anyplace else, at least not at scale. And that's the white space. And we're talking about hundreds, thousands of molecules. And as we go down that path and demonstrate the performance properties, that unlocks value. And that value translates to price. And that's super important because Alissa was mentioning before the criticality of being able to develop a business case for why different players along the value chain should be incented to adopt these new technologies. And we need to be aware that it's not a level playing field, right? Like there's no subsidy for bioconversion technologies the way there is for petroleum and for the petrochemical industry. I mean, we talk about policy and we talk about a shifting regulatory landscape, but I don't know, I think I read it was $54 billion of petrochemical lobbying dollars just in the US alone. I mean, startups in bioconversion do not have that kind of, political engagement to help move policy and like the regulatory environment. And so it has to be based on out competing on performance. And the way that we're doing that is to get at these chemistries biologically that unlock performance properties.
Mm-hmm.
Yes, speaking to just like of the lobbying perspective on it, it's going to be really interesting when it comes to labeling, so that if you come up with something awesome, can you label it so that it's desirable wording, one, and then secondarily, because it's a biosynthetic, is it going to fit into that same, if it just so happens that you're manufacturing overseas and importing stuff into a country, is it going to be grouped with that same synthetics at a high duty rate? And so there's so many interesting aspects from a regulation standpoint as well.
But you can take inspiration from things like the food and nutrition industry or say the tobacco industry to get a sense for where the competitive pressures are going to lie and how the competitive response is going to be to make it as confusing as possible for the consumer.
Yeah.
Just to make sure that we stay the course and don't execute the transition. That's why it's up to us around the table to move towards a future that is post-petroleum.
Yeah, I mean, we're seeing that already with manufactured cellulose fiber, same type of deal. It's kind of crazy. Let's see here. We have 2 minutes. So I wanted to make sure I had this other question answered. This one's for you, Pasha. So let's see. It is, how critical does end-of-life recyclability versus compostability factor into material selection and adoption of biosynthetics?
Yeah, I think that's a good one. I mean, we've talked about this throughout the panel, but there's no doubt that there's definitely some holes in the recycling systems, and the statistics that I've been hearing lately, and it keeps getting worse. What is it? 15 million garments are entering Ghana every week, right? That is an unbelievable amount of product coming from the global north. And ultimately, it's going to require all of us to work together to figure it out. And yeah, I think ideally, in an ideal world where there's a perfect stream, it would just be a closed loop recycling system where we could be getting these garments back and textile to textile recycling. But we have to be, realistic about what really is happening and where these garments are going. So I think it's going to also require us to really work together with all these different levels of the supply chain, and even collaborate with these places that are just getting inundated with garment waste, like Ghana, right? They need to be a part of the conversation and talk about circularity. And circularity is more than just recycling. It can be biodegradability, it's decomposition, right? It's this whole system, and there's tighter circles, there's bigger circles, and we just need to really, that is a huge opportunity for us to work on. So, and time is running out because I can't believe that each year this number gets bigger and bigger and bigger. So it's pretty wild.
Thank you all so much for this really interesting discussion. I'm so sorry we have more questions in the chat, but I have to cut it off because I don't want everyone to miss the performance session that's now happening on the main stage. But I'm sure all of these panelists would be willing to answer questions. You can message them directly through the platform. But thank you all so much, and I hope to see everybody in the audience over on the stage.
Yeah, thank you. This has been
Thanks,
awesome.
guys.
Thanks, everyone.
Yeah, thank you.
Hope you feel better, Charles.
Thank you.
Yeah, thanks.
All right.
Thanks,
See you
Louis.
guys.
All right.
Bye-bye.
Thanks all.